My name is Professor Shannon Gracie. We are covering section 10.3 of Blitzer's Introductory and Intermediate Algebra for College Students text. We will be learning how to multiply and simplify radical expressions today. So why don't you guys go ahead and warm up and we will get started with the lesson. So pause the movie, warm it up, and check to see how you did. Okay, let's see how you did. Here we have the same base of 4, and so we'll be, oops, that's a little thick. We'll be subtracting the exponents. They both have the same denominator, so we'll have 4 to the 1/3. It can't be simplified further, so we're done. Next up, we have 196 to the 1/2 because we have a product raised to a power. We have x to the 10th raised to the 1/2. And we have y to the 22nd raised to the 1/2 power. This gives us, I don't know if you realize that 196 is the same as 14 squared. X to the 10th raised to the 1/2, we multiply the powers, and so we'll multiply the 22 and the 1/2 for the powers on the y. 14 to the 2 times 1/2, and then x will be raised to the 5th and y will be raised to the 11th. And finally we just get 14 because 2 times 1/2 is 1. X to the 5th, y to the 11th. And we're done. How'd you do? Awesome. All right, now factor out the greatest common factor. So when you look at the constants, and I'm sure you noticed that you could factor out an 8. Now be careful because x is the same as x to the 1. So you want to factor out the smallest power on the variable, which in this case is going to be a 1/4. So here, notice that we just need a 1 here. Well, let's write it like this. 8x to the 1/4 times 1 gives us 8x to the 1/4, and then plus 8x to the 1/4 times, we need a 2 to make that a product of 16, and 1/4, remember you're adding exponents when you multiply same bases. So do you see that 1/4 plus 3/4 is 1? So now using the distributive law, we'll be factoring out our 8x to the 1/4, and we've got 1 plus 2x to the 3/4 remaining. So here you have, if you think of this as the common and factor, that's where this guy went. And then this was our part from the first term, and this was our part from the second term. So we just rewrote this as an equivalent expression in factored form. All right, next up we need to multiply. So I'll distribute the x to the 1/2 times this second the second factor. So we have x to the 3/2, and then minus x to the 1/2 times 10. And then plus 3 times x to the 3/2 plus or minus 3 times 10. So we will have x to the 1/2 plus 3 halves minus, I'll just put the constant first, I'll commute these terms, 10x to the 1 half plus 3x to the 3 halves minus 30. So we get x to the 4 halves minus 10x to the 1 half plus 3x to the 3 halves minus 30. So this will give us a result of x squared. If we put it in descending order, we'll have plus 3x to the 3 halves minus 10x to the 1 half minus 30. We're all done. So, these are all the same kinds of things that you did in introductory algebra, except now we have exponents that can be fractions. Okay. The product rule for radicals. The product rule for radicals. So, here we go. If the nth root of a and the nth root of b are real numbers, then it turns out that the nth root of a times the nth root of b is equal to the nth root of a times b. So let's just suppose that you had let's look at n equal to 3. All right, so let's just suppose that you had the cube root of a times the cube root of b. I'm just showing you why this rule works. So here, if you rewrote these in rational exponents, you would have a to the 1/3 times b to the 1/3. But remember that that's equivalent to ab all raised to the 1/3, which in turn is equivalent to the cube root of a times b. So that's why this rule works. It all comes from properties of exponents. So if you're ever unsure, if you're making up your own math or anything, then revert to rational exponent notation and see if you're following the rules. So what this means is the product of two nth roots is the nth root of the product. Now I made a typo here. This should be radicans. Oops. Okay. So, next up, with this one, you check to make sure the index on each radical matches. So remember, this is a square root, this is a square root. They're being multiplied, so you can write them as one happy square root with that product of the two radicands, which ends up giving us, whoops, sorry, I was giving the result. 2 times 11, that's using our rule, which gives us an end result of the square root of 22. Okay, again checking, I've got a cube root here and a cube root here, and I'm multiplying. So I can rewrite this as the cube root of the product of the radicands, which is 4x times 12x, which would give me the cube root of 48x squared. Next up, we have a square root and a square root. So this will be the square root of quantity x minus 1 times quantity x plus 1, which of course is the square root of quantity x squared minus 1. Okay, so simplifying radical expressions by factoring. A radical expression whose index is n is simplified when its radicand has no factors that are perfect nth powers. To simplify, use the following procedure. So this is, a guideline. You might have a little bit different way of doing it, but as long as you're following all the properties of exponents and the rules for radicals, you should be fine. So write the radicand as the product of two factors, one of which is the greatest perfect nth power. Use the product rule to take the nth root of each factor and then find the nth root of the perfect nth power. So let's see what this all means. Okay, so the square root of 12. So we have a square root here. So our goal is to figure out how we can rewrite 12 as the product of perfect squares. So here we go. The square root of 12 is equal to the square root of 4 times 3. I picked 4 because 4 is a perfect square. Well, we can actually go ahead and split this as root 4 times root 3. Root 4 has a result of 2, so we get 2 times root 3, but you know what? It's written like this, 2 root 3. That means 2 times root 3. Okay, so just so that you can match it up, the square root of 4 was 2, and we got the result of 2 times root 3. Okay, so now what kind of root do we have? Good, we have a cube root. So now we're looking for perfect cubes. So you want to be able to recognize perfect cubes. So this is the cube root of 27 is a perfect cube. 27 times 3 is 81. And then x cubed is a perfect cube, and we have times x squared. So now we're going to write this as the product of two cube roots. The first one is going to have all the perfect cubes. Okay. The second one is going to consist of the factors we had left over. So the 3 and the x squared are in the second one. 3 cubed, remember, is 27. So now, every time we match the power with the index on the radical, it's just that number that comes out. And we get 3 times x, and then here times the cube root of 3x squared. But remember, this is just 3x, and then cube root of 3x squared. That means times in between. All right. How are we doing so far? So just so that we know, what matched up, all of this resulted here in this one here. And 27 times 3, actually, I'll show you. The 27 is here with the 3 cubed. Okay. So next up, we have a square root. So we want perfect squares. Well, 2 times 144 is 288, and I know that 144 is a perfect square. So 144 times 2. Now here's the trick here. We want to write these variables here raised to something being squared. Well, when you raise a power to a power, you multiply. So I'm going to first write the exponents I only want even ones because anything times 2 is going to be even. So I want things that are a multiple of 2. So x to the 11th is equivalent to x to the 10th times x to the 1. I'm kind of going backwards from what we're used to doing with properties of exponents. And then 14 is even, so I'll keep y to the 14th as it is. Z cubed we can write as z squared times z to the 1. Okay. So now what we'll have is 144 is 12 squared. X to the 10th is x to the 5th squared. Can you visualize that? That would be x to the 5 times 2, which is x to the 10th. And then we'll have y to the 14th, so that'd be y to the 7th squared, because 7 times 2 is 14. I have the z being squared. And then I'll have this other radical with the leftover stuff that can't be, raised to the second power. So that is the 2 from up here, x to the 1, which is x, z to the 1, which is z. So again, x to the 10th, actually, x to the 10th is x to the 5th squared. Y to the 14th is y to the 7th squared. All right, so when I evaluate this stuff here, not that one. When I evaluate this guy here, I still want that red to show as red. Then what we'll have is we'll have a result of 12 x to the 5th, y to the 7th. We don't need to put the absolute value bars around anything because it said that assume all variables represent positive numbers. Okay. And then we'll have a z, and that's going to be times the square root of 2xz. And we're done. Okay? So for the remainder of the chapter, in situations that don't involve functions, we're going to assume that no radicans involve negative quantities raised to even powers. So based on this assumption, absolute value bars are not necessary when taking even roots. So that means that for any non-negative real number a, the nth root of a to the n will be a. Okay, so with that in mind, with this new rule in mind, when it says simplify, starting in this chapter from this point on, 10.3, we don't need the absolute value bars. Now, if you haven't done the problem sets from 10.1 and 10.2, you need to keep the absolute value bars on those sections. So just be careful, and when you read the directions, I'll be very specific when I give the exam. Okay, so here we go. 3 times 36 is equivalent to 108. So we can write that as 36 times 3. X to the 4th will work because 4 is a multiple of 2. And then if I write y cubed as y squared times y to the 1, then I have myself, set up for what I need. So then I'll have 6 squared is 36. X squared squared is x to the fourth. I have my y squared. And what I have left over is just the 3y. Okay, so we'll get 6 x squared y times the square root of 3y is our result. So this here is equivalent to this. And, you know, x to the fourth was the x squared squared, and y cubed, this was our y cubed here. Our y cubed was the y squared times y to the 1. Alrighty, so why don't you pause the movie and you guys try the next couple problems and see how you do, and check your work. Okay, let's see how you did. We have a fifth root, so we want things that are raised to the fifth power. So this will be equivalent to the fifth root of, I know that 32 times 2 is 64, and 32 is the same as 2 to the fifth. So I'm going to write the 64 as 32 times 2. We need things that are multiples of 5, so I'll have to write x to the eighth as x to the fifth times x cubed. Y to the 10th is fine because 10 is a multiple of 5. And then z to the fifth is fine. 5 is a multiple of 5. So then we will have the fifth root of 2 to the fifth is 32. X to the fifth. Now, y to the 10th we need to write as y raised to something raised to the fifth. So we'll have y squared to the fifth, and then z is already to the fifth. We will have remaining the fifth root of, there's a 2 left over, and then there was an x cubed remaining. And this is a little bit high. Need to be careful with the indices. So we can take out a 2, an x, a y squared, and a z. And then we'll have times the fifth root of 2x cubed. How'd you do? Awesome. So this here is all equivalent to this. So we had x to the eighth we had to be a bit tricky with, right? And the y to the 10th we rewrote here. Okay. So, next up, we now have a fourth root. So we want things when multiplied to themselves 4 times. That's what we're looking for. We want to raise things to the fourth power. So this will be the fourth root of, I know that 16 is 2 to the fourth. So 16 times 2. We need things that are multiple of 4 for the powers, so x to the 12th works, but we need to rewrite y to the 15th as y to the 12th times y cubed. So this will give us the fourth root of 2 to the fourth, x cubed to the fourth. That's how we manipulated x to the 12th. Similarly, we'll have y cubed to the fourth times the fourth root of 2y cubed is remaining. So we will get 2x cubed y cubed times the fourth root of 2y cubed, and we're done. So again, these are equivalent. These parts are equivalent here. Okay? All right. So now, just more practice. So why don't we pause the movie? Why don't we pause the movie and you guys try to do this last page of 10.3 lecture and see how you do. Okay. All right, let's see how you fared on this one. So let's write this as 1 happy square root, because notice none of this can be simplified as it stands. So we're going to write this as the square root of 15xy times 3xy, which is 45x squared y squared. Now I know that 45 is 9 times 5, and 9 is a perfect square. So I will have the square root of 3 squared times x squared times y squared. And then what's left over is the square root of 5. So we'll just get 3 times x times y times the square root of 5, and we're done. And again, this here is equivalent to this when you after evaluating the square root. Okay. So next up we have a cube root. So we're looking for perfect cubes. I don't see any perfect cubes here. So let's multiply these two, use the product rule for these two radicals. So we'd get 10 x squared y times 200 x squared y squared, all under 1 cube root. Put this closer in. So this will be the cube root of 2000 x to the fourth y cubed, which will be the cube root of 1000 times 2. That's my 2000 times x cubed times x. That's my x to the fourth. And then times y cubed. This will be the cube root of 10 cubed x cubed y cubed, and then times the cube root. What do we have left? We have a 2 times x. So here, the first one, we can take out a 10 xy, and then we're left with the cube root of 2x. We're all set. So again, this here we were able to evaluate as 10xy. All right. So the next example just says to simplify. So now you have to decide if you need to multiply and simplify or what to do. Okay? And there's a couple ways a person could go about it. I am going to go ahead and write it as 1 square root So we'll have 5xy times 10xy squared. This is going to be, that y squared I'm going to leave alone because it's a square root. 5 times 10 is 50. Okay, so this is 50 x squared y squared times y. Now, perfect square as a factor of 50 is, good, 25. So we'll have 25 times x squared times y squared times y. Actually, my apologies, 25 times 2 times x squared times y squared times y. Now, 25 is 5 squared, and we have x squared, and we have a y squared. And the second square root that we multiply will be the things that are not perfect squares and can't be, so 2 times y. So then from this first one, we'll get 5 times x times y times the square root of 2y, and we're done. Hopefully these are going better. People tend to find these a bit difficult, the radicals. Okay, so next up we have a fifth root. So I'm going to go ahead and multiply everything together and make 1/5 root and then go from there. So going a little bit faster, do you see 8 times 8 is 64. X to the 4th times x is x to the 5th. Y cubed times y to the 9th is y to the 12th. Z cubed times z to the 8th is z to the 11th. Now I need to look for perfect, results of raising something to the 5th. So I know that 32 is 2 to the 5th, and 32 times 2 is 64. X to the 5th we'll leave alone. Now y to the 12th, I need things that are multiples of 5, so I'm going to write y to the 12th as y to the 10th times y squared. And same with z to the 11th, z to the 10th times z to the 1. So now, now rewriting, we'll have 32 is the same as 2 to the 5th times x to the 5th times, good, y squared to the 5th times z squared to the 5th. So those will be all the perfect fifth powers. And then times the 5th root of everything left over. So I had a 2, I had a y squared, and I had a z to the 1. So I will get 2x y squared z squared times the 5th root of 2y squared z. And this here is equivalent to all this. Okay. Next up, we have a lot going on here. This is all being multiplied together. This is my thought. Let's multiply the things that are being multiplied to these 4th roots together. So I'm basically going to use the commutative law. I'm going to say that we're going to do 2x squared times y times negative 32 xy squared first, okay? And then times the 4th root of 8xy, so I'm going to put them under one happy 4th root, and then times 2x squared y cubed. Now, 2 times negative 32 is negative 64. X squared times x to the 1 is x cubed. Y times y squared is y cubed. Times the fourth root of 8 times 2 is 16. X times x squared is x cubed. Y times y cubed is y to the fourth. So this will be negative 64 x cubed y cubed times the fourth root of 2 to the fourth times y to the fourth times the fourth root of x cubed. So we will get negative 64 x cubed y cubed times whatever we bring out of this radical, which is 2y, times the fourth root of x cubed. So this here was evaluated as this 2y here, and anytime you evaluate a root, you multiply it to whatever number is already being multiplied to that root. So then we will get negative 128 from the negative 64 times 2 x cubed y to the fourth, and then times the fourth root of x cubed, and we're done. And that wraps up the lecture for 10.3. So have a fabulous day. Make sure you do some of the homework problems like I always tell you. And I will, quote unquote, see you soon. Bye.